Hello everyone, I'm Dr. Anil Agarwal and I'm happy to have this opportunity to teach this NPTEL course on the design of steel concrete composite structures. Let me first begin with a brief introduction about myself. I am a faculty in the Department of Civil Engineering at IIT Hyderabad. I have done my BTech and MTech from IIT Kanpur and I did my PhD from Purdue University. I specialize in the behavior and design of structures in extreme events. The extreme events may mean fire, earthquake, impact, and so on. Also, when it comes to structural systems, I work on all kinds of structural systems, but I focus more primarily on steel and steel concrete composites. When it comes to the different types of loading conditions, I did mention extreme events. Also, I work in the area of uh, multi-hazard cases such as post-earthquake fire, post-impact fire, and also I'm an experimentalist. I work in the lab and I work with large scale, full scale experimental investigations into the structural behavior. Also, parallelly, I also work in the area of the development of lightweight, very highly material efficient composite systems such as FRP for infrastructure applications. Uh, this presentation I'm making to introduce this course. So let me start the introduction with the beautiful pictures of these six magnificent buildings. You are all familiar with, I'm sure, with most of these buildings. The first one is the Empire State Building. The second one is the World Trade Center. This was a building until 2001 uh, in New York City. The third one is Willis Tower. The fourth one is Petronas Tower. The fifth one is Taipei 101. And the sixth one is Burj Khalifa. Now, here, out of these six buildings, first thing is that there is a list of these buildings, and only these six buildings qualify to be in this list. Which list is this? Are these the tallest buildings at present in the world? No. There are buildings which are taller than these. Then which list is this? The list belongs to the buildings who have held the title of being tallest at any time in the past 100 years. So Empire State Building was finished in 1931, and since then until 1972, it remained the tallest building, and then World Trade Center took over, followed by the Willis Tower and so on. Now, here, this list can be separated into two subcategories. The first three, they belong to USA or the Western Hemisphere, you may say, and the second three, they belong to the Eastern Hemisphere, right? Uh, but from structural engineering point of view, there is another demarcation between between the two categories. The first three buildings, they are predominantly steel type buildings. And the second set, these are predominantly concrete, reinforced concrete type buildings. Now, when I say these are predominantly steel buildings, what I essentially mean is that majority of the material that was used was steel. And in this case, the majority of the material that was used was concrete. But it does not mean that the other material was not used in any of these buildings. Both steel and concrete were used quite heavily in all these buildings. So that is the question, a very unanswered question for a very long time. What is the more efficient material? Is it steel or is it concrete? The advantages of using steel is that it offers a lightweight solution for the same problem. It allows for a rapid construction. However, it is a more expensive material. Concrete, on the other hand, is a cheaper material, but it provides a heavier structural system. Okay, and depending on which country, which space you are, there may be a different ratio of steel and concrete, which may give you an optimum solution. So there is not a clear optimum solution in steel or concrete alone, right? And that's where the composite construction comes into play. When we deal with steel construction, the floor system is almost always composite. When we deal with reinforced concrete systems, even there, if a very high efficiency of material utilization or area utilization is required, even then composite or steel construction becomes mandatory. And some of these buildings, even though they are predominantly RC construction, they use composite or steel components quite handsomely. Okay, so what is this course going to talk about? We will be talking about different structural members and structural systems, how they work together. Here is a picture of the Taipei 101, as I mentioned, and they, even though this building was predominantly reinforced concrete construction, some components, some of the columns in this building were very heavy composite columns. So this course will have several modules. The first module will be about the introduction. The second module will be about the reinforced concrete slabs and floor systems. That will extend into composite beam systems, wherein we will learn how the slab system works with steel beams. And then composite columns. Composite columns is pretty much what qualifies a building as a composite building. Uh, the composite columns can be of two kinds typically. One is CFT column, which is concrete filled steel tube column, or it could be an encased column where the hot roll section is placed inside concrete. Then connections between composite members. It could be composite columns, it could be composite beams, or it could be composite column steel beams or composite beams steel columns. Those connections are quite challenging often, and we will discuss what different types of connections options are available. And then the final topic will be miscellaneous, where we will be discussing the shear wall design in a limited sense, how to design shear walls using composite technology, and also how to design composite structural systems for some of the extreme events such as fire, etc. The course will have some regular reference material. I have not been able to find very good quality textbooks in the Indian context on composite construction. R.P. Johnson's book, published by Willie Blackwell, will be the primary reference material. Either third or fourth edition will be okay. You don't have to have copies of these books readily with you, but if you have them, it will be helpful. Um, we will be referring to different international and Indian design codes, and these are all freely available. You can download them from the internet, and the commentaries are all, some of them have a very detailed commentary that will be helpful for this course. The course will have three levels of evaluation. The first one would be questioning during the lectures. I will take a small pause, I will ask a question, then I will answer the question myself. That will help you understand whether you are keeping up with the pace of the class. Also, there will be weekly assignments that you are required to solve and submit and evaluate yourself. There will be 25% weightage for this weekly assignment, and the final exam will have 75% weightage. If you want to get a certificate for this course, you need to complete this evaluation, that is assignments and final exam. And I think you have to pay some fee to be able to appear for that exam. So with this, I conclude this introduction of this course. I hope you would register for this course and enjoy participating in this course. Thank you for your time.